Have you ever wondered how our digital world, all of it, was built? I mean, could a single mind over 1,500 years ago really lay the groundwork for everything we do today? Well, it all started in what you could call a golden age of discovery, with a man who gave us the language to measure infinity itself. So let's just dive right into the mind of this genius with his own words. Just as a man in a boat moving forward sees the stationary objects on the shore as moving backward. Now, that isn't just some pretty poetry. It was a seriously profound scientific insight that was about to challenge everything people thought they knew about their own place in the universe. To really get the man, you've got to understand the world he lived in. This was a time when science and art were just exploding with new ideas. We're talking about a golden age dawning, and the world that created a genius. Okay, so picture this. We're in the 5th century CE, right in the middle of the Gupta Empire in India. This was an era of incredible stability, peace, and prosperity, which created the perfect incubator for brilliant minds to pop up and start tackling the biggest questions you can imagine. And this is the world that gave us our hero, a young man, stylus in hand, literally ready to write the future. And here he is, Aryabhata, born in 476 CE. This man was a true pioneer. He almost single-handedly shifted Indian science away from being about ritual and tradition and toward rigorous, analytical mathematics. He wasn't just, looking up at the stars, he was calculating them. So his home base was the vibrant city of Kusamapura, which is modern-day Patna. He wasn't just some lone scholar. He was the head of an institution, a kulapa. A lot of historians think he probably led the whole astronomy department at the legendary Nalanda University. But what's absolutely mind-blowing is that he wrote his masterpiece, the Aryabhatiya, this incredible 121-verse collection of all his knowledge, when he was just 23 years old. 23! Now, before he could even start to measure the universe, Aryabhata had a problem. The tools for calculation were, frankly, clunky and super limited. So what did he do? He first had to invent a whole new language for numbers. This is the story of the alphabet of infinity. His innovation was just brilliant, an alphabetic and positional system. So what that means is the value of a character changed depending on its position. Simple, right? The consonants were the numbers, but the vowels were the real key. They acted like power-ups, changing the position and multiplying the value of the consonants. This system allowed him to write out numbers all the way up to 10 to the power of 18. That's a billion. And with this new number language, he could invent totally new tools. He introduced the world to the concept of ja, which is the Sanskrit word for a half-chord. And this idea is the direct ancestor of the trigonometric sine function that we all learn about in school. But the journey of the word itself is just incredible. From the Sanskrit ja, it was copied into Arabic as jibba, but later someone misread that as jibe, which means pocket. So then Latin translators turned that into sinus, which of course became our sine. So a huge cosmic idea was passed along through a simple mistranslation. Now here's where it gets really fun. Check out how he applied all this. His method for calculating pi sounds almost like a riddle. He says, add 4 to 100, multiply by 8, add 62,000. And that result, he tells us, is the circumference for a circle with a diameter of 20,000. So if you do the math, his calculation gives you a value for pi of 3.1416. That is accurate to 4 decimal places, which is amazing for the time. But here's the kicker. The most crucial part is the word he used, asana, which means approaching. This tiny detail suggests he knew pi was an irrational number, something that you could get closer and closer to, but never perfectly express. And he knew this 1,300 years before European mathematicians would formally prove it. Just incredible. But Aryabhata's most revolutionary idea wasn't actually about numbers. It was about our place in the cosmos. He was about to challenge ancient, unquestioned dogma with a model of a world in motion. For centuries, the accepted truth was the geocentric model, a stationary Earth sitting right at the center of everything. But Aryabhata comes along and proposes something totally radical. He says the stars are fixed, and it's the Earth that's actually rotating on its axis. And this is where he brings us right back to that boat on the river. As the boat moves forward, the trees on the shore look like they're sliding backward. He just applied that same exact logic to the heavens. The Earth is the boat, and the stars are the trees. And the calculations he made based on this model, they were just mind-bogglingly precise. He calculated the Earth's rotation at 23 hours, 56 minutes, and 4.1 seconds. That's less than a tenth of a second off the modern value. And his number for the Earth's circumference was off by only 0.2%. So with this new model, he just started shattering ancient myths. He explained that eclipses weren't caused by some celestial demons or angry gods. No, they were caused by the simple, predictable shadows of the Earth and the moon. He used these intricate instruments he'd built to show that the moon and the planets don't even have their own light. They just shine by reflecting sunlight. This was science replacing superstition, plain and simple. All of this incredible work was laying the foundation for what might be the most powerful idea of them all, the power of nothing and the Indian genesis of zero. Okay, now here's a really subtle but absolutely critical point. If you read the Aryabhatiya, you won't actually find a symbol for zero. But his entire place value system, the thing that made his math so powerful, would have been totally impossible without the concept of zero. He needed a void, a term called ka, to act as a placeholder. You see, the idea of zero didn't just appear out of nowhere. It evolved over generations, right there in India. The earliest physical proof we have is from something called the Bakshali manuscript, which could be from as far back as the 3rd or 4th century. And in it, a small dot, the shunya bindu, was used as a placeholder. Then Aryabhata's system made that concept absolutely essential for math, but it was another genius who really gave it its power. And that was the 7th century astronomer Brahmagupta. He was the first one to treat zero not just as a placeholder, but as a real number with its own set of rules. He's the one who defined that x plus 0 equals x, and how multiplication works. He even defined negative numbers as debts and positive numbers as fortunes, with 0 as the perfect balancing point between them. He gave nothingness its logic. Now, an idea this revolutionary was just too powerful to stay in one place. It was truly a gift to the world. And now, we're going to follow the incredible journey of that idea. So, in 773 CE, a caravan carried these scrolls from India to the bustling city of Baghdad, home to the famous House of Wisdom. And there, those Sanskrit texts were translated into Arabic. Then, around 825 CE, the great Persian mathematician Al-Khwarizmi wrote a whole book on this Hindu reckoning, which spread the system all across the Islamic world. And finally, in 1202, after seeing it used in North Africa, the Italian mathematician Fibonacci introduced it to Europe. The idea traveled, the language on the scrolls changing from Sanskrit to Arabic to Latin. So why does any of this matter to you and me today? Well, because from that void, from that concept of nothing, our entire virtual world was born. This is the digital legacy. I mean, when you really connect all the dots, his legacy is just astounding. You've got the foundations of modern algebra, the sine function in trigonometry, the model of a rotating Earth, scientific explanations for eclipses, and of course, the conceptual framework for zero. All of these pillars of modern science trace their roots right back to Aryabhata and the brilliant minds of his time. And in 1975, India gave this legacy a beautiful tribute by naming its very first satellite Aryabhata. Its amazing 26-face structure soared up into a whole new kind of sky. A binary sky, made entirely of zeros and ones. Aryabhata's work is the ultimate proof that the most revolutionary, world-changing ideas can come from completely reimagining what we think of as nothing. Which leaves us with a question for our own time. What future will we build from nothing?